Well, now we are using the dimensional equation for testing the correctness of a particular formula. Now, in order to find whether the formula is correct or not, we consider an example. T is equal to 2 pi under root L over G. T is the time period, that is time taken to complete one vibration by a pendulum bob. L is taken as the length of the pendulum. G is acceleration due to gravity. The value of G is normally taken as 9.8 meters per second square, but in some cases when it is not being provided, in that case we take 10 meters per second square. Now, the left hand side of this formula is T and the right hand side is 2 pi under root L over G. So, the dimensional equation of T, that is indicated as m naught L naught T1, and in the right hand side dimensional equation of 2 pi under root L over G can be written as m naught L1 T naught over L power 1 T power minus 2 and the whole power is half. Another thing you will remember that 2 pi is dimensionless. It has no units. So now after simplifying, we'll come to know that left hand side dimensional equation and right hand side of the dimensional of the formula have the same dimension. Therefore, the given formula is correct. Now, we can use the dimensional equations for deriving the formula. So, to derive the formula by dimensional analysis method, we take certain example. Suppose that there is a physical quantity S, and this physical quantity depends on another quantity, that is P, Q, and R. So, in order to establish the formula, we take the very first step, that is S is proportional to P to the power A, Q to the power B, R to the power C. Then proportionality sign is removed and we write a constant. So S is equal to K into P to the power A, Q to the power B, R to the power C, and we mark it as equation number 1. Now consider the dimensional formula of each quantity in both sides. So one side is S, that is S is taken as the dimension as m to the power x, L to the power y, and t to the power z. Similarly, for P, Q, and R, we compute the dimensions in terms of m, L, and t. In one case, it is powers are x1, y1, z1, whole power is a. Then the powers are x2, y2, and z2. The whole power is b. Then it is powers will be x3, y3, z to the power 3, and the whole power is c. Then we simplify the result by using the laws of exponent, that when the bases are same, the powers are added. So, in the final conclusion, we write m to the power x, L to the power y, t to the power z is equal to. And now you can see the right hand side, that is m to the power ax1 plus bx2 plus cx3, then L to the power ay1 plus by2 plus cy3, then t to the power az1 plus bz2 plus cz3. Now comparing the powers of both sides, we make two equations. So exponents are equated like ax1 plus bx2 plus cx3 equated with x. ay1 plus by2 plus cy3 is equated with y. That is second and third equations. Now we come to the fourth equation, that is az1 plus bz2 plus cz3 is equal to z. Now we can solve second equation, the third equation, the fourth equation by using the concept of determinants or by using the crisscross method in simultaneous equation, which we have done in 11th class and in the lower classes. The value of A, B, and C will be taken as M, N, and O, and that is found, and then substitute the values M, N, and O in equation 1. Then obtained formula will be S is equal to P to the power M, Q to the power N, R to the power O. Now we take another example. the time of oscillation t depends upon density d, radius r, and surface tension s. The point to remember is that is for density, we will use the formula mass over volume, and volume can be taken as L cube. The radius is length only, so R will be taken in terms of L. Surface tension is S, and it is taken as force per unit area, that is force per unit length. So surface tension is defined as force per unit length. We have to put the dimension of force and length, and we have to obtain the formula for T by dimensional method. So first of all, what we do is T is proportional to d to the power a, r to the power b, s to the power c. That is, T is equal to k into d to the power a, r to the power b, s to the power c. We mark it as equation number 1. What is d representing here? Density, r representing length, and s representing surface tension, that is force per unit length. Now, taking dimensions of each quantity in both sides, we will put the dimensions of time, and in the right side, we will put the dimensions for density, then length, and the surface tension. That is, surface tension is force per unit length. Now, next is what we have to do. We have to just equate the values on both sides. So, comparing the dimensions of both sides, we get equation 2, 3, and 4. On substituting the values a, b, and c in equation number 1, we will find the value of t, which is found to be r square under root d over s. Drawback of the dimensional analysis. Now, there are certain drawbacks, there are certain good things in the dimensional analysis, there are certain uses in the dimensional analysis, and now there are certain drawbacks in the dimensional analysis. While driving a formula, the proportionality or proportionality constant cannot be found. The formula for a physical quantity depending on more than 3 other physical quantities cannot be derived, because if it is more than 3 variables, we have to use the higher complex mechanism. But up to 3 variables, we can use determinants. So, the dimensional analysis can be used for checking the formula. The equation of the type V is equal to U plus minus AT cannot be derived. They can be checked only. The equations containing trigonometrical functions like sine theta or cos theta, the logarithmic functions log x cube, etc., the exponential functions e to the power x and e to the power x square, etc., cannot be derived, but they can be checked only. It gives no information whether a physical quantity is a vector or a scalar. The formula which is dimensionally correct may or may not be physically correct.